Injectivity is a new adjective for functions. A function is injective if it's one-to-one, meaning that for every x value, it gets sent to a y value and a unique y value. There's no other x value that gets sent to that y value. So every input has a unique output. That's what an injective function looks like. So in other words, it's going to pass that horizontal line test now, right? Because there, every y value only has one x value that goes to it. Right? This y value has this x value. Right? This y value has this x value. But a function will not pass the horizontal line test if a single y value has several x values that go to it. All right, so let's think about example 13.3. F of x is x squared. G of x is the square root of 4x minus 7. We show that f of x is not injective, but g of x is injective. So the definition of injectivity is if f of x equals f of y, then this is going to imply that x is equal to y. Right? That's exactly what we just talked about up there. If you fix a certain output, then your function can only cross at one x value. So if your two outputs are equal, then you have to be talking about the same point. There's no two different points that give you the same function value. So this is where we're going to start. If we have the two functions equaling each other, so if x squared is equal to y squared, does that imply that x is equal to y? Well, no, we can come up with a counterexample, right? Let's let x be minus 2 and let y be 2. Now, these are obviously not equal to, but they map to the same point underneath the x squared function, right? F of x is minus 2 squared, that's 4. F at y is 2 squared, that's also 4. Right, so x squared, this function here, does not pass the horizontal line test because we just found two different inputs that get mapped to the same output. So it's not injective. But g of x, we're going to show is injective. And we're going to start in the same way. We're going to let g of x equal g of y. So this means that square root 4x minus 7 is equal to square root 4x, or sorry, square root 4y minus 7. So what we're going to do now is if these two are equal to each other, I can peel off that square root by squaring both sides. And if I square both sides, that means 4x minus 7 is equal to 4y minus 7. I add 7 to both sides, and I divide by 4. So here we actually did finally get down to x has to be equal to y if these two functions are equal to each other. So therefore, g of x is injective. It's going to pass the horizontal line test. Right? If you graphed 4x minus 7, then you'd have a y-intercept at 7/4. But it would look like that. It would pass the horizontal line test. So if g of x is equal to g of y, and that means that x is equal to y, this is injective. If it doesn't mean that x is equal to y, then it's not injective. And to show that something's not injective, you just need to come up with a counterexample.